Hello grade 9 students. Today I am here to teach you chapter 24 in your textbook. That's probability. So in this lesson we are identifying what are random experiments and write the sample space of a random experiment and identify equally likely outcomes and probability of an event and the sample space when the outcomes are equally likely. So we'll look at what are random experiments. So take a coin. What are the two sides you can get? Head or tail. Above figure show two sides of a fair coin. One side is called head and the other side we call tail. So what are the possible outcomes when tossing a coin? When you toss it, what are the two possible outcomes? You can get head or tail. So we know that one of these outcomes will appear before tossing the coin. And we cannot identify which side will appear next. It can be head or it can be tail. So we can perform this experiment several times and there is no pattern of the outcomes appear when tossing the coin. So we call those are random experiment. So we don't know what we will get. So you can toss at any time, several number of times, and you can see there's no pattern with the outcomes. Look at this one. These are the numbers appear when throwing a die. So die means a cube. You get 6 sides. So here 1, 2, 3, 4, 5, 6. So we know that one of these numbers 1, 2, 3, 4, 5, 6 will appear before throwing the die. We cannot identify which side will appear next. We can perform this experiment several times and there is no pattern of the outcomes appear when throwing a die. So this is also a random experiment. Identify random experiments or not. Put correct sign for random experiments and cross sign for not random experiments. Throw a regular tetrahedron with numbers 1, 2, 3, 4 and identify the side land on the table. So these all are regular. Sides means all sides are equal. So you get different numbers. So this is a random experiment. So we can get either 1, 2, 3, 4 and we don't know which side you can get. So this is a random experiment. Take a ball randomly from a bag with 5 identical red glass balls. So there are 5 identical glass balls. You select one. We don't know what we will get. So that's a random experiment. Take a ball randomly from 10 balls labeled 1 to 10. So 1 to 10 labeled. So take a ball. We don't know what we will get. There's no pattern of the numbers you are getting. So that's a random experiment. Label 1, 2, 3, 4, 5, 6 on a matchstick box and identify where it lands. Now the problem in matchstick box is that's a cuboid. All sides are not the same. You get rectangles, different sizes rectangles. So this is not a random experiment. Throw a bottle lid and identify the side it lands. So bottle lid, you get 2 different sides. So we don't know which side we will get. So that's not a random experiment. And throw a stone and identify the side it lands. So in a stone you get different shapes. So we don't know which side you get most because not all the sides are the same. So here this is also not a random experiment. So what is sample space? So set of all possible outcomes of a random experiment is called the sample space, and we use the letter S, capital S, for sample space. Now think about this example. Toss a coin once and write down the sample space. And what is this one? In brackets S. We call it number of outcomes in the sample. So we can count and see how many numbers are there. So we'll find out when you toss a coin once, what are the possibilities you can get? You can get head or tail. So H I put for head, tail for T. Now 2 outcomes are there. So what's the number of outcomes in sample space? You get 2. Write down the sample space when tossing a regular tetrahedron with numbers 1 to 4. So 4 sides are there. So what are the numbers you can get? 1, 2, 3, 4. 4 possibilities are there. So here number of outcomes in the sample space is 4. Write down the sample space when taking a ball labeled R1, R2, R3, B1, B2 randomly. So what are the possibilities? You can get R1 or R2, R3, B1, B2. So what are the possibilities? 1, 2, 3, 4, 5, and we say number of outcomes in the sample space, that's 5. There are several cards with prime numbers less than 20. Write down the sample space when taking a card randomly. So what are prime numbers less than 20? Starting with 2. 2 is a prime number. 3, 5, 7, 11, 13, 17, 19. Those are the prime numbers less than 20. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 are there. So we say number of outcomes in the sample space is 8. Write down the sample space when tossing a coin twice. So you can get outcome for the first toss and outcome for the second toss. So if we take first toss, you can get head or tail. These are the possibilities. But first time toss, when you take first toss, you can get head for the second toss, as well as you can get tail. So with same head with the first toss, you can get either head or tail in the second toss. With the tail in the first toss, you can get head or tail. So when you are taking all possibilities, how we write down the sample space? So I can write this is H, H, head and head. So here I can write with brackets H comma H. That's one possibility. This possibility I can write H comma T, head with tail. And the other one, tail with head and tail with tail. So I took the first outcome as the first letter. So this means first head, second head. First head, second tail. First tail, second head. First tail, second tail. Now how many outcomes are there? 1, 2, 3, 4 outcomes in the sample space. In one box there are 2 red balls, R1 and R2. In another box there are 2 blue balls, B1 and B2. So what are the possible outcomes? So we can say you can get red one with blue one. And also you can get red one with blue 2. And first time you can get red 2 with blue 1 or red 2 with blue 2. So those are the possibilities. So how can we write down the sample space? So I can write R1, B1. That's one outcome. R1, B2. That's the second one. R2, B1. That's the third one. R2, B2. That's the fourth one. So how many outcomes are there? 1, 2, 3, 4. 4 outcomes are there. What are fair objects? There are two sides of a coin. We know that there are two sides. If all the sides are equally likely outcomes, it is a fair coin. So all sides are equally likely, we say that's a fair coin. So the chance of getting head or the chance of getting tail is the same, equally likely. So this is a fair object. So the coin is a fair object. So we call that's a fair coin. There are 6 sides, 1, 2, 3, 4, 5, 6 of a die. If all the sides are equally likely outcomes, it is a fair die. So the chance of getting 1 is the same as chance of getting 6. So we call that's a fair die. What are equally likely outcomes? When you toss a fair coin, getting head and getting tail are equally likely outcomes. So chances are the same. Those are equally likely outcomes. When you throw a fair regular tetrahedron, getting 1, 2, 3, 4 are equally likely outcomes because all sides are the same. When throwing a die with numbers 1, 1, 2, 2, 2, 3, these are not equally likely because you get more 2's here. So getting 2 is higher than getting 1 and getting 3 is the lowest. So these are not equally likely outcomes. If the numbers are different, it's a equally likely one. Now look at this one. In a bag, there are 4 red marbles and 2 blue marbles. When taking a marble from a bag, there is a high possibility of taking a red one because there are more red ones than blue ones. So these are not equally likely outcomes. Now you know how to identify equally likely outcomes or random experiment or fair objects. If there are equally likely outcomes, put the correct sign, and if not, put a cross sign. Throwing a stone and observe sides. Stone, you don't get same size. So that's not a equally likely outcome. Throwing a matchstick box and identify, so the sides are different. You get different rectangles. That's not a equally likely outcome. Throwing a funnel and observe the side it lands, so you always get one side. So that's not a equally likely outcome. There are 3 toffees of same kind in a box. Taking a toffee at random, all are same kind. So that's equally likely outcomes. Taking a card from same sized cards, 1 to 10. So same size, so that's equally likely outcomes. Taking a marble from a bag with 10 identical marbles, yes, that's an equally likely outcome because all are identical. Finding probabilities of equally likely events. Throwing a tetrahedron with sides 1, 2, 3, 4 and find the probability of getting a prime number. Now we are trying to find out the probability, but before that we are trying to find out the sample space. So what are the possibilities? You can get 1, 2, 3, 4. 4 possibilities. So what's the number of outcomes? That's 4. That's the sample space. what are the prime numbers in that? So prime numbers is another set A. So here prime numbers are 2 and 3 only here. So what's the number of elements in A? That's 2. 2 and 3. So how can we find out the probability? So probability of getting any event A is number of outcomes in A. That means in A divide by total number of outcomes in the sample space, in S. So you need to know how we find out the probability. Probability of any event is number of outcomes in that event divided by the total number of outcomes in the sample space. According to this one, what is NA? We found NA is 2. NS is 4. So here 2 over 4, you can simplify and write 1 over 2. You can divide by 2. So remember this formula. Probability of any event is number of elements in A divided by number of elements in the sample space. So likewise, what is probability of getting any event B? Number of elements in the B event and the number of elements in the sample space. What is the probability of getting C? Number of elements in C over number of elements in the sample space. What about PY? Y is any event. Number of elements in Y divided by number of elements in the sample space. Randomly take one card from 10 cards labeled 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Write down the sample space. So you can get any value from that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 possibilities are there. So the number of outcomes in S sample space is 10. If A is a set of numbers that are multiples of 3, find number of elements in A. Now A means multiples. Now identify what are the multiples of 3. What are the multiples? You can get 3, 6 and then 9. Those are the multiples of 3. So what is the number of elements in A? That's 1, 2, 3. You get 3 there. Find the probability of A. Now we found number of elements in the sample space is 10. Here 3. So what's the probability of A? You can use the formula. Number of elements in A divided by number of elements in the sample space. This is 3 and this is 10. So what's the probability? 3 over 10. If B is getting an odd number, so we have to identify what is the event B. Odd numbers there. What are the odd numbers? 1, 3, 5, 7, 9. 1, 3, 5, 7, 9. So what is number of elements in B? 1, 2, 3, 4, 5. So how we find out the probability of B? You can find number of elements in B, divide by number of elements in the sample space. So we know that this is 10 and B is 5. 5 over 10. Simplify, you can get 1 over 2. Divide both the numerator and the denominator by 5. Throw a die with numbers 1, 2, 3, 4, 5, 6. Write down the sample space and find NS. So what are the possibilities? You can get 1, 2, 3, 4, 5, 6. Then what's the sample space is here. Number of elements in the sample space. Outcomes 1, 2, 3, 4, 5, 6. That's 6. If A is a set of getting multiples of 2, so you have to identify the event A. Multiples of 2. It can be 2, 4 or 6. So what's the number of outcomes in A? 1, 2, 3. So you get 3. What's the probability of A? That means number of elements in A divided by number of elements in the sample space. In A, that's 3. NS is 6. So 3 over 6. Divide by 3 both the numerator and the denominator. You get half. If B is the set of getting a number more than 3, another event B getting a number more than 3. So 3 is not included, so 4, 5, 6. So it can be 4, 5 or 6. And what's in B? Number of outcomes in B, 1, 2, 3. So that's 3. So what's the probability of getting event B? Number of elements in B divided by number of elements in the sample space. 3 over NS is 6. 3 over 6 means divide by 3, you get half. Look at this question. There are 3 red, 2 blue and 2 green identical marbles in a box. A child is taking a marble from the box. Write down the sample space of the event and find NS. So what are the possible outcomes? So here 3 red ones are there. So we have to label it as R1, R2, R3. 3 red ones. 2 blue ones, B1, B2. And 2 green ones, G1 and G2. So all together, how many possibilities? You can get 1, 2, 3, 4, 5, 6, 7 possibilities. So number of outcomes in S is equal to 7. If A is taking a red marble, find NA. So A means, what are the possibilities? Red marble. It can be R1, R2 or R3. So what's in A? Number of outcomes in A? 1, 2, 3. 3 outcomes are there. So what's the probability of A? Probability of A is number of outcomes in A divided by number of outcomes in the sample space. So 3 over 7. So that's the probability of getting A. If B is taking a blue marble, find NB. So what is the event B? Event B is taking a blue one. How many blue ones are there? 2 blue ones, B1 and B2. So the possibilities are B1 and B2. So altogether 2. So NB is 2. So what's the probability? Probability of B is number of outcomes in B divided by number of outcomes in the sample space. So you get 2 here. Altogether, what's NS? 7. So here 7. Now another event C, taking a green marble. So what are the possibilities? How many green ones are there? 2. G1 and G2. 2 possibilities are there. So that means number of elements or number of outcomes is 2. So find the probability of getting a green marble. So probability of getting green marble means C is equal to NC over ns. That's 2 over 7. There are 8 cards labeled R1, B, P, R2, J, R3, M, R4. Different letters are there. Take one card at random. Write down the sample space. So what's the sample space? You can get R1, B, P, R2, J, R3, M, R4. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. So NS equals 8. 8 possibilities are there. So you are asked to find out if A is getting any type of R letter, find NA. So A is an event. You can get any R value. So what are the R values you get? R letters, you can get R1, R2, R3 or R4. So 1, 2, 3, 4. 4 possibilities are there. So NA equals 4. If B is a letter that is not R, so not R means what are the possibilities? You can write all the other letters. B1, so B, P, J, B, P, J. What are the other letters? B, P, J, M. Those are not R. So how many are there? All the outcomes, 1, 2, 3, 4. 4 outcomes are there. So what's the probability of getting B? Probability of getting B is number of elements in B over number of elements in the sample space. So here elements or outcomes, same thing. NB, that's 4. NS, we'll look at it. NS is 8. So 4 over 8, you can simplify and write down half. Throw a die, write down the sample space and find NS. So when you throw a die, what are the numbers you can get? 1, 2, 3, 4, 5, 6. 6 numbers you can get. So what is NS? 6. If K is getting an odd number, find NK. So what are the odd numbers there? 1, 3, 5. So 3 possibilities are there. So NK is 3. So what is the probability of getting K? Probability of getting K equals NK over NS. 3 over 6. When you simplify, you get half. If L is getting a prime number, so what are the possibilities of getting prime number? 2, 3, 5. Those are the possibilities. 2, 3, 5. So how many are there? 3. So what's the probability of getting L? Number of outcomes divided by the total number of outcomes. 3 over, what's NS? That's 6. 3 over 6. Or you can simplify and write half. If M is getting an odd number or a prime number, find NM. So M is an event that you can get either prime or odd. So when you take the sample, 1 is odd, 2 prime, 3 prime and 5 odd and prime. So 1, 2, 3, 5. 1, 2, 3, 5. Those are the possibilities you can get. So how many are there? So NM is equal to 1, 2, 3, 4. 4 possibilities are there. That's 4. So what's the probability of getting M? Number of elements in M divided by number of elements in the sample space. 4 over NS, that's 6. Divide by 2, you get 2 over 3. Look at this spinning wheel. The wheel rotates and observe the number appear with the arrow. Find the sample space and NS. So what are the possibilities you can get? You can get 1, 2, 3, 4, 5, 6, 7, 8. So S says 1, 2, 3, 4, 5, 6, 7, 8. So how many outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 outcomes are there. If X is an event getting an even number, what are the possibilities? Even numbers there. 2, 4, 6 and 8. So what's the probability of X? So before that you need to find out number of elements in X. 1, 2, 3, 4. And what's the probability of getting X? Number of elements in X divided by number of elements in the sample space. 4 over 8. Divide by 4, you get 1 over 2. If Y is getting a number greater than 5, what are the numbers greater than 5? 5 is not included. 6, 7, 8. 6, 7, 8. So what is NY? That's 3. So what is PY? Probability of getting Y. NY over NS. NY is 3. What's NS? That's 8. So the probability is 3 over 8. Another event Z is equal to getting an odd number greater than 5. Odd number greater than 5, odd number greater than 5, it can be 7. Only one possibility is there. So what is number of elements in Z? That's 1. So what's the probability of getting Z? Number of elements in Z divided by number of elements in the sample space. 1 over NS is 8. That's 1 over 8. Look at this example. There are two boxes, X and Y. In X, 2 balls are labeled as A and B. In Y, 2 balls are labeled as 1 and 2. Randomly select a ball from box X and then a ball from box Y. Write down all possibilities of taking 2 balls and find number of elements of outcomes in sample space. So what are the possibilities? Now you can write at once. If you take A from here, you can get 1 there. Or A from the first box, that's X, and you can get 2. B from the first box, that's X box, and 1 from the next one, or B with 2. So those are the possibilities you can get. So what's the sample space is this? So number of elements or outcomes in the sample space, 1, 2, 3, 4. 4 possibilities are there. If A is getting A first and then 1. A first and then 1. So that means here this possibility. So A is just one possibility, that A and 1. So what's number of elements in A? You get one possibility. So what's the probability of A? Na over Ns. That means 1 over. Ns means that's 4. So 1 over 4. If B is getting a ball labeled 2, second time, find NB. So what are the possibilities? Second time you need to get 2. You can get 2 with A or 2 with B. Those are the two possibilities you can get. So what's NB? NB is 2. So what's the probability of getting B? Number of elements in B over total number of outcomes. That's 2 here. What is NS? NS is 4. So 4 is the denominator. You can divide by 2 and write half. Now we'll look at the exercises in your textbook. Exercise 24.1. For each of the following experiments in the column to the right, mark correct sign if it is a random experiment and the cross sign if it is not a random experiment. Rolling an unbiased tetrahedral die with its faces numbered from 1 to 4 and recording the number on the face which touches the table. So this is unbiased and all faces are equal. So this is a random event. So you can put a correct sign. Drawing a bead from a bag which contains beads of one color and recording its color. So here there are a lot of beads and you get 1 and observe the color. Is it random? All are the same color ones. So here it says contains beads of one color. So always you get the same color. So this is not a random experiment. Throwing a ball at a target and observing whether it hits the target or not. So we don't know whether it hits or not. So that's a random event. Look at the next one. Planting 5 radish seeds and recording the number of seeds that germinate in 5 days. 5 radish seeds from 1 radish. So it's not random. Checking whether a door opens when a key picked at random from a bunch of 3 keys is used. So it is a random experiment. So 3 keys are there and you are selecting one. Tossing a ball in the air and observing whether it falls to the ground. So it always falls. That's not a random experiment. And drawing out 2 cards from a box containing 3 cards, each with one of the numbers 1, 3, 5 written on it, and observing whether the sum of the 2 numbers on the 2 cards that are drawn is an odd number. Now when you take any 2 cards, these all are odd numbers. Odd plus odd, always an even number. 1 plus 3. 1 plus 5, 3 plus 5, always you get even number. So this is not a random one because you are not getting odd number. Always you get even number. So this is not random. Example number 1. Write the sample space for the experiment of rolling an unbiased tetrahedral die with its faces numbered from 1 to 4 and recording the number on the face which touches the table. So what's the sample space? You can get either 1, 2, 3, 4. That's the sample space. Then example number 2, write the sample space for the experiment of drawing a bead from a bag which contains 2 black beads, B1 and B2, and 3 white beads, W1, W2 and W3 respectively, which are identical in all other aspects. What is the value of NS? So what's the sample space? You can get B1, B2, W1, W2 or W3. So what's the number? Altogether 1, 2, 3, 4, 5. 5 possibilities are there. Example number 3. There are 2 cards such that R is written on one side and Y is written on the other side. The cards are tossed simultaneously and the letters turned up is recorded. Write the sample space of this experiment. So 2 cards are there. So you can get, in one card you can get R and the next one Y. Or R with R. Red with red, Y with R. Or first card Y and the second card red, also possible. If this one is R is the first one, you can get other possibility as well. Y first and R second. Or you can get Y and Y. So you get 4 possibilities. So what's NS? 4. Exercise 24.2. Write the sample space of each of the following experiments. Randomly drawing a pen from a bag which contains 1 pen each of the colors blue, red, black and green and recording the color. Assume that the pens are identical in all aspects except the color. So what's the sample space? You can get blue, red, black or green. So 4 possibilities are there. Recording the number on the card that is drawn at random from a bag containing 11 identical cards numbered 5 to 15. So what are the possibilities you can get? You can get 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So altogether 11 cards are there. Recording the number, the arrow points to when the disc shown in the figure is spun and allowed to stop freely. So what are the possibilities you can get? 1, 2, 3, 4, 5, 6, 7 and 8. A bag contains 4 milk flavored toffees and 3 orange flavored toffees of the same size and shape, randomly drawing a toffee and recording its flavor. So what are the possibilities? You can say 3 oranges are there. So orange 1, orange 2, orange 3. Or you can get, what are they? 4 milk flavored toffees. M1, M2, M3 or M4. 4 milk flavored and 3 orange flavored. Recording the sides that turn up when a coin is tossed twice. So we know that first one head, second one tail. Or first one head and second one head. And first one tail with second one head. Or first one tail and the second one tail. So 4 possibilities are there. Exercise 24.3. For each of the following experiments, determine whether the outcomes are equally likely or not. The 4 faces of an unbiased tetrahedral die are painted in 4 different colors, namely red, blue, yellow and green, recording the color of the face which turns up when it is rolled. So all sides are equal. Equal faces means all faces are the same and only difference is the color. So this is equally likely. Recording the side which turns up when a fair coin is tossed. So that's also fair. Object is taken, that's equally likely. Recording the number on the card which is drawn at random from 10 identical cards which are numbered. 1 4 times, 2 3 times, 3 twice and 4. So here the chance of getting 1 is more than the other number. So not equally likely. Recording the number on the side which touches the ground when a prism, as shown in the figure, with its sides marked with the numbers 1, 2, 3, 4, 5 is rolled once. So the shapes are different. This is a triangle, these are other 3 sides rectangles. So this is not equally likely. Recording the color of the card drawn randomly from a bag which contains 3 red cards and 4 blue cards which are identical in all other aspects. So same type of cards. So this is equally likely. Recording the letter to which the indicator, which is fixed at the center of a circular disc, points when the disc, which has been divided into 8 equal sectors and named A, B, C, D, E, F, G, H as shown in the figure, is spun and allowed to stop freely. So all sectors are equal, so equally likely. This one, recording the color on which the indicator, which is fixed to the center of the disc, falls when it is spun and allowed to stop freely. Here the disc is divided into unequal sectors. So you get more chance when it is blue, less chance when it is purple color. So this is not equally likely. Example number 1. Consider the experiment of observing the side that turns up when an unbiased coin is tossed once. Write the sample space of this experiment and find NS. So what are the possibilities? You can get either head or tail. So what is the sample size here? Number of elements in S is 2. Then second part, if the event A is head, turns up. Write the elements in A. So A is just getting head. So number of outcomes in A is just 1. And next one, find probability of A, the probability that heads turns up. So probability of A is NA over NS. 1 outcome out of 2. So that's half. Example 2. Consider the experiment of recording the number on the face that touches the table when an unbiased tetrahedral die with its faces numbered 1, 2, 3, 4 is rolled. Find the probability of getting 2. First, we have to find out the sample space. You can get 1, 2, 3, 4. And NS is 4. Now, getting 2 means if any event is getting only 2. How many outcomes are there? That's just 1. So, we need probability of A getting 2. NA over NS. NA is 1 out of 4. So 1 over 4. Second one, find the probability of getting an even number. What are the possibilities? We'll say B is getting even number. 2, 4. So you get 2 possibilities. So what's the probability of getting even number? NB over NS, that's 2 over 4. 2 over 4 you can simplify and write half. Third one, find the probability of getting a number greater than 1. Greater than 1 will take C. What are the numbers? It can be 2, 3, 4. So NC is equal to 3. So what's the probability of getting C? Number greater than 3. Number greater than 1. So you get NC over NS. That's 3 over 4. Exercise 24.4. Consider the experiment of rolling an unbiased cubic die with its faces numbered 1 to 6 and recording the number on the face that turns up. Write the sample space S of all the possible outcomes of this experiment. You can get 1, 2, 3, 4, 5, 6. Find the value of NS. You get 6 possibilities. That's 6. If A is that event of an even number turning up, write the elements of A and find NA. What are the even numbers you can get? 2, 4, 6. So what's the number there then? 1, 2, 3. 3 possibilities are there. Find probability of A. That means NA over NB. So what's the number of outcomes in A? That's 3. Total is 6. 3 over 6. You can divide by 3 and write that's half. Find the probability of a prime number turning up. So we'll take any event C. That's prime numbers. 2, 3, 5. Those are the possibilities. So number of outcomes is 3. So what is the probability of getting a prime number? NC over NS. That's 3 over total. Here, this is S. So, this one is S, total number. So, here, what's the total number there? 6. 3 over 6, that's half. Question number 2. Consider the experiment of drawing a card at random from a bag containing 8 identical cards marked with letters A, B, C, D, E, F, G, H and recording the letter on it. So, write down the sample space. All possibilities are there. A, B, C, D, E, F, G, H. Find the probability of drawing the card with the letter B marked on it. So, we'll say event A is just getting letter B. That's only one possibility is there. NA is 1. Here what is NS? 8. So what's the probability? Probability of getting B is 1 over 8. Find the probability of drawing a card with a vowel marked on it. So we'll take B as vowel. What are the vowels? A, E. That's all. 2 vowels are there. So what's the outcome? Here number of elements. That's 2 possibilities out of 8. So what's the probability of getting a vowel? 2 possibilities out of altogether 8. 2 over 8, you can simplify and write 1 over 4. Find the probability of drawing a card with the letter K marked on it. You don't get letter K. So here, if it's C is the event, no outcomes there. So what is NC? That's 0. So what's the probability of getting any K letter? It's not possible. 0 divided by total is 0. So probability is 0. There are 25 identical cards numbered from 1 to 25 in a box. Consider the experiment of drawing a card at random from the box and recording the number on it. Find the probability of drawing the card with 8 marked on it. So when you take 1 to 25, 25 cards are there. 8, only 1 card, 1 out of 25. So straight away you can write down probability of getting number 8 is 1 card out of 25 cards. 1 over 25. So you don't need to write down the sample space and everything, number of outcomes. Straight away you should be able to write down the probability. Find the probability of drawing a card with a number which is a multiple of 5. So we have to write down what are the possibilities. Multiple of 5. So 1 to 25. So 5 times 2, 10. 10, 5 times 3, 15, 20 and 25. So these are the possibilities. And now how many elements are there? Outcomes? 1, 2, 3, 4, 5 outcomes are there. Then what's the probability of getting a number is multiple of 5. So 5 possibilities are there out of 25. Divide by 5, you get 1 over 5. Find the probability of drawing a card with an odd number marked on it. So what are the possibilities? You can get odd numbers. 1 to 25. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. What else? 21, 23, and 25. Those are odd numbers. How many cards are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 possibilities are there. So what's the probability of getting a number? Probability of getting odd number. 13 over 25. Find the probability of drawing a card with a square number marked on it. So we'll take the event is C. So what are the square numbers? 1. 2 squared is 4. 3 squared 9. 4 squared 16. 5 squared 25. Those are the possibilities. So what is the number? 1, 2, 3, 4, 5 possibilities are there. So what's the probability of getting a square number? 5 out of total 25 outcomes. Divide by 5, you get 1 over 5. Consider the experiment of spinning the disc in the figure and recording the color of the sector in which the arrow head lands when the disc stops spinning. Find the probability of arrow head landing in the dark blue sector. So here, probability of getting dark blue. So you can do without writing. Altogether, how many parts are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 parts are there, equal parts. And dark blue, there are 2. So 2 possibilities are there. So 2 over 8. Simplify, you get 1 over 4. Find the probability of arrowhead landing in the red sector. Do we get a red color? So no possibility. So probability of getting red color is 0. So we can't take this one as red. This is like brown. So red is 0 possibility. Find the probability of the arrowhead landing in the yellow sector. So there's 1 possibility. 1 possibility out of 8. In a multiple choice question paper, of the 5 answers that are given for a question, only 1 answer is correct. A person picks one of the answers randomly for a question to which he does not know the answer. What is the probability of that answer being correct? So only 1 correct answer out of 5 answers. So probability of being correct is 1 possibility out of 5 answers, 1 over 5. And being incorrect, so it can be all other 4. Not the correct one. So when you take out the correct one, there are 4 incorrect answers. So 4 out of 5. 4 over 5. In a bag, there are 3 red beads, 2 black beads and 5 white beads which are identical in all other aspects. Consider the experiment of randomly drawing a bead from the bag and recording its color. Find the probability of drawing a red bead. Probability of getting a red bead. What are the possibilities? 3 red, 2 black and 5. So altogether 3 plus 2, 5. 5 plus 5, 10. 10 possibilities are there. Taking a red one, there are 3 red ones. 3 possibilities are there. So the probability becomes 3/10. Find the probability of drawing a blue bead. Now you should be able to do without the sample space. So this is blue bead. How many blue beads are there? There are no blue beads. Only red, black and white. So what's the possibility? So this is 0. Probability is 0. Find the probability of drawing either a red bead or a white bead. Red or white. So we have to count all together how many red ones and white ones. 3 red ones and 5. Altogether 8. You get 8 red or white out of, what's the total? 10. Divide by 2, you get 4/5. Find the probability of drawing a black bead. How many black ones are there? 2 black beads. So 2 possibilities are there out of 10. Divide by 2, you get 1/5. Consider the experiment of recording the day of the week on which a student picked at random was born. Find the probability of the student being a person who was born on a Monday. So how many days are there? 7 days. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. So 7 days are there. So probability getting a Monday day is 1 out of 7. Find the probability of student being a person who was born on a Sunday. So same like the previous probability. So only one Sunday out of 7 days. So 1/7. Find the probability of the student being a person who was born on either a Wednesday or a Friday. So there are 2 possibilities now. Wednesday or Friday. So 2 possibilities are there out of 7. Find the probability of the student being a person who was born on a day which is neither a Saturday nor a Sunday. So when you take out these 2, how many days are there? How many days? You get Monday, Tuesday, Wednesday, Thursday, Friday only. So 5. So here probability of getting neither Sunday nor Saturday is 5 out of 7. So we completed all theory related to probability. In a random experiment with equally likely outcomes, how we find out the probability? Probability of a selected outcome is number of elements in the event over number of elements in the sample space. So here, how you find out the probability? The formula is number of elements or outcomes in A over number of elements in the sample space. Practice all probability questions because you will get a question in your O-level exam. So grade 10, 11, we are doing probability again.